Improve your network automation from one-off scripts only you can use to safe, robust automations you can share with your entire IT organization with iTential. Find out more at www.itential.com/packetpushers. That's www.itential.com/packetpushers. Welcome to Heavy Networking from the Packet Pushers. I'm Ethan Banks along with Drew Conray Murray. You can connect with us on LinkedIn and on the Packet Pushers Slack group, which you can join via packetpushers.net/community. Today, we are covering operational technology, or OT, network operations. Now, you might be asking, what's an operational technology network? Well, it's the network that connects the controllers for industrial equipment that's affecting something in the physical world. By contrast, an IT network, which is what most of us think of, an IT network would be mostly about making information available somewhere. OT networks connect devices like SCADA and industrial Internet of Things and HVAC systems. They might use Ethernet and IP, but they might use some other kind of a network transport like wireless LoRaWAN. OT networks and IT networks might be completely separated as part of a security design, or they might be converged. Our guest today is Dan Massameno, the Director of Network and Cloud Architecture at Yale University. Dan was with us on episode 720 back in February 2024, where we discussed their Radius deployment in detail. More details on deck with Dan as we discuss Yale's OT network deployment, including their experience with Cisco's SD-Access. Dan, welcome back to Heavy Networking.
Drew, Ethan, thank you very much for having me on. I just want to start by saying I do not represent my employer or the vendors. The view expressed on this podcast are my own. But that said, happy to talk about OT and our experiences with you.
Okay, so OT network, just to help people who've not heard of this before, flesh this idea out in their mind. I know it's not rocket science, but an OT network, it's got some different characteristics than an IT network, Dan. So maybe talk about the clients to begin. What's different about OT clients than the laptops, servers, wireless clients that we're familiar with on IT networks?
Great, yeah. So some people call it IoT, industrial IoT, building automation control systems. It covers a lot of things that might be headless devices, and they're usually interfacing with building automation control systems, lighting systems, everything from maybe the automatic shades on windows to HVAC systems. It started out as, if historically going backwards, as a network of probably serial interfaces, RS-232, RS-485, and we're talking, kilobits per second. Maybe hundreds of, kilobits per second. And these networks would be put in place for 15 plus years when you commission the building. Think, the lifespan of the entire building is how long these are put in for. And you get the sense of the turnover or how much innovation is going on in this space. So it's quite a much larger time horizon of what we do with Windows and Macs and stuff like that. They're also interested in maximum stability. There's no Microsoft Patch Tuesday. If you think you're cool because your Catalyst 6500 has been running for more than 10 years, you got nothing on these guys. As long as the power is running at your building, they don't stop. They just keep going. And that's what they're designing for, right? Because you don't want the HVAC system or the alarm system or something to be done, to have an interruption, and they're looking for a much higher number of nines of reliability than, say, even a data center sometimes.
So when putting together an OT network, designing it, what are kind of the chief parameters that an architect would be working with? Or is an architect even involved in building an OT network? Or is it just something that sort of comes together and then somebody else has to come along and be like, okay, let's figure this out?
So they have the vendors have their own architects, and they'll actually do a lot of design. A lot of design work goes into a big building. They're targeting maximum stability, simple, KISS for, KISS on a whole new level, right? It's very simple setups usually. It's simple stuff. At one point in time, they were putting in networks, and, it was more likely that DHCP or DNS would fail on the enterprise network than it would be than, say, an OT technician would accidentally assign the same address to two devices and create an outage. So when you're talking, what's more likely, that I use static IPs and my life is good, or I use the enterprise DHCP and maybe that has an outage? That's why you saw OT networks going with static IPs. They don't use DNS. They don't use any of the modern things that we are doing because it made sense. That was the equation they were looking at. And for practical reasons, these things were just plain simple networks.
So static configurations like that, right? They don't break. You reduce dependencies on external services like DHCP and DNS. If you're not using them, then, off you go. I assume for DNS, if they needed name resolution, you'd populate a host file, something like that?
Or they use raw IP addresses in their programming. They
Okay.
do everything that we say shouldn't be done. They're
Yeah.
doing because it's a mindset that came from early on. So you're talking. It used to be in like a serial chain of devices across a daisy chain of serial interfaces, and there'd be little dip switches where you'd set
Hmm.
this is device number 14 on a chain, and there's only enough dip switches to specify 256 devices. So they're super comfortable with statically addressing everything, and then they just carried that forward when the industry turned into Ethernet.
Hmm.
So, but we are still talking about devices with IP addresses over an Ethernet network.
Almost always it will be IP.
Okay.
And that sounds funny to say it like that, but there are some devices that are just a layer two. They figured out how to do Ethernet and not IP. It's just some
Mhm.
sort of layer two protocol that's totally bound to come across somebody's desk if you're doing an OT network or integrating the enterprise network into the OT network. Uh, we have here over 300 buildings, and they were all built at different times or renovated at different times. That means I have GE, Johnson Controls, Automated Logic Corporation, Honeywell, Tritium, Siemens, and
Hmm.
more. And I'm not even in the facilities department. I get brought in when the facilities and I are working on a big rollout like SD-Access, and we're working with the facilities department. I mean, we have a great relationship, and we knew way ahead of time when we started doing SD-Access that we were going to need to build that relationship. Where previously, I mean, our groups didn't really need to talk to each other too much. We did operate a OT network that was a completely separate OT network. And it was air gapped, and network engineering did stand up, whatever Hewlett Packard switches or something needed to go into a basement or a penthouse. And it was a separate network. Everything was separate. So it was twice the management to maintain it, twice everything. Um, some of the reasons why we're moving towards a converged network, we have a lot of green initiatives, like probably a lot of organizations have. And the size of the OT network is increasing. In 2022, the facilities department deployed a new software package that is managing 650 air handling units. That year, when we put that software in, they saved 17.7 billion BTU, which
Wow.
was about more than $500 million. And uh, that I read the article afterwards, and I think it's because basically they were finding air handling, they were finding compressors and stuff that were maybe doing a heat cycle and the cooling cycle at the same time, and they
Hmm.
just had to
Oh
roll
boy.
people, roll people out there to fix it. Now, if you had 60 people on your team, you could probably handle 300 buildings. But teams are not that big, so they have to make do with what they can, and that means software can help them get their jobs done more easily, and it hits the bottom line. And it was a great initiative.
Hmm. Now, is that the convergence, moving towards a converged network for OT and IT? Does that also help you with the resilience, with the uptime? Because you mentioned how critically important that was, and I'm imagining like, well, yeah, I mean, you don't have dual attached IoT devices, right? I mean, so there'd still be a lot of SPOFs, I would imagine, in the default kind of network configuration.
Yeah, the individual OT devices just have an Ethernet port, right? So
Yeah.
that's singly attached, but that's similar to how we have like workstations and stuff. But once it
Hmm.
got to the switch, the old network, it would go into like an old HP switch or something. We're converting everything to Cisco with SD-Access, but it would go into a switch, and then it would have a 1 gig uplink, a single uplink. With our SD-Access rollout, all the closet switches have dual uplinks, 10 gig or 25 gigabits per second. And then they have fast Ethernet, gigabit Ethernet. Interestingly, Cisco in some of their newer blades for the Cat 9400 is dropping support for 10 megabit per second Ethernet.
Oh, interesting.
Yeah, I was
Huh.
surprised to see that. They're thinking, oh, who does that anymore? What do we need to put it in the chipset for? They still maintain support on their stackable switches. They have support. Clearly, they need to maintain support indefinitely on their industrial switches because this stuff is sometimes quite
Mm.
old. So we are converging. Now, I'll say this is that if you're dealing with OT stuff that's industrial, heavy industrial, like robotic arms and sensors, tight micro millisecond, control loops, If you're controlling like gas centrifuges or chemical plants, uh, SD-Access might not be a good fit. There's a lot of moving parts to make SD-Access work smoothly, and that wasn't what it was really built for.
Hmm.
But if you're doing temperature sensors, so you have something checking in every 60 seconds to see what the temperature is, or you're going to activate a blower motor or open a damper, we've been having good luck with it. We've been integrating it and putting it onto SD-Access in many situations. We just have to figure out a way to do it, and then we get it to integrate onto our one converged platform.
Oh, we're going to get there with SD access. Yeah, we're going to get
Can
there
you
to
take a
them.
minute to kind of tell us, what kind of systems you are supporting? Because I could conceive of a university like Yale having some pretty critical infrastructure like robotic arms or really sensitive scientific equipment.
So if there's a robotic arm, it's probably in the computer science department. So we let them do their own thing. Our facilities group it's mainly what we're doing, and there's some specialized stuff I'm sure we'll touch on later. But it's mainly HVAC,
Okay.
some lighting controllers, shade controllers. Some of the new green initiatives means that we want to block the sunlight from coming into a building to heat it up in
Hmm.
the summertime, and so that can be an automated schedule or based on how much sunlight is coming in. That kind of stuff I think fits well. It's not like a automotive assembly line.
Right.
Uh,
Okay.
yeah, so I think that's a good fit. If SD-Access ever becomes a really good fit, there's no particular reason why SD-Access couldn't work in an heavy industrial setting. But probably you want to balance the nature of what you want to do, because that's probably a dedicated network.
Hmm.
Whereas a campus with 300 buildings, you don't need a dedicated network for a lot of this stuff.
And when we're talking about IoT and OT convergence, you mentioned facilities, they're sort of used to running these devices. You mentioned having to build a relationship with them. Can you talk about sort of where the responsibilities, diverge and come together and how you built that relationship? Because that's, I think, something that often gets overlooked.
Uh, yeah, the relationships are super important. So we started working with them years ago when we first started designing SD-Access and the campus, and they would be our liaisons to talking to the vendors. So some vendors work directly with us. Other vendors is kind of a reseller or a MSP type, where a consultant group is the one that sold it to us and puts it
Hmm.
in. So I'd say Siemens and Johnson Controls are two of the bigger vendors. GE does different things. Like GE will be monitoring the power going into and out of all the branch circuits, electrical systems and stuff. Or GE might be it might be GE software that monitors steam. So we use steam to distribute energy around the campus,
Hmm.
things like that. So the facilities department would be our liaisons to the vendors. The vendors would come in and talk to us about what's this BACnet IP protocol, which we'll talk about. What other protocols is it working? Is SD-Access even going to work with the way that this thing works? And usually the answer is yes. It might need some tweaks. We used to
Question
have a
about
separate, I was going to say, we used to have a separate network for public safety, facilities, the School of Medicine, the regular campus network. And that's one of the nice things that SD-Access brings to us is now all those are converged onto a single physical platform, but they're all virtual networks on top. So the OT network does have a separate virtual network
yeah.
that is their own thing. And then within that virtual network, we have separate subnets uh, in the same virtual network for the different vendors.
Well, one other question about your infrastructure generally, and then I want to get us to get into SD access some more. But that's gateways, Dan. A lot of IoT networks have some kind of a gateway that translates from whatever the IoT protocol is to Ethernet IP. Are you dealing with gateways at all?
Yeah, so it used to be historically the gateway would be the device in between that RS-485 serial chain of devices that were rather, I mean, I don't say dumb devices, but they just did a serial interface. And then the gateway would be the system between those and the Ethernet network. Now, fast forward, all those things on the chain are Ethernet, but you still need
Mhm.
in a lot of designs, you still need that gateway that has maybe a little bit of a better CPU, maybe has a better protocol that it can do that's simpler to implement. That bridges between that raw network that is just on that one floor and daisy chains through a bunch of blower motors to the regular, let's call the enterprise OT network, which is the wider, bigger OT network that you still haven't gotten to the enterprise campus backbone, but it's still a dedicated network. But that bridge helps hide sometimes a 20-to-1 ratio of 20 devices behind that gateway. And then you just have the team, like my team, just has to deal with that one device because that's all we see that's connected to our network.
So your IT responsibility kind of stops at the gateway, and facilities will handle the devices behind the gateway, you're saying?
Yeah, facilities and or the vendor the facilities is working with. So they came to us and they said, hey, we want the ability to, like, say, roll our truck out there at 9 p.m. and fix a problem with a HVAC system and not need to put in a ticket with ServiceNow and get network engineering involved or central IT involved. That flexibility is really valuable to us. And the only way we see that being able to be done is if we had our own little network behind the gateway that we can call our own. So that was an interesting design decision that we decided to roll with on multiple areas.
Does that gateway also potentially serve as like a boundary, a security boundary, because you may not want these devices on the other end, the OT devices, to be reachable via the internet or to reach out from your network to the internet?
A little bit. So our OT network on SD-Access is secured. Only way in and out is through a firewall. And we're trying to design out of the network any laptops that people use to troubleshoot or diagnose or do commissioning. There's no servers that we're putting on that network. It's just the IoT devices. And then when the technician needs to come in and maybe manually do some troubleshooting, they're on a laptop somewhere, and we use Cisco AnyConnect to validate who they are, do force two-factor authentication, and then they're allowed to, they're in the facilities group. So then they're allowed to talk to that network. But otherwise, you're not getting into that network unless you have physical access. You could, if you get physical access or somehow get onto it physically. So that's the way we're securing it. But yes, it does create a little bit of a little mini firewall without being a firewall, a breakpoint. Past that point is just a separate network. Now, when they go to do addressing, sometimes they say, we're just going to do 192.168.0.x. And then the second floor is 1, and then just increment the third octet. And we said, well, wait a second. Let's at least allocate you from our official enterprise IPAM legit subnets, knowing that today we never need to route a packet to and from these subnets. They're their own islands. But if ever in the future we did have a system where we wanted to integrate it better or have the networking work and routed, at least you wouldn't have an address conflict with all other 300 buildings that you did. So that one change will not pay dividends today because they are separate islands. But if they ever weren't, we'd be set to go.
But future Dan might be like, oh, thank goodness we did that.
Absolutely. I mean, there's other problems I'm sure that would happen, but maybe it wouldn't be an addressing problem.
A quick sponsor break courtesy of iTential. iTential is the network automation platform you get to build robust, self-service automation that is safe for your entire IT organization. Now, if you've been writing your own automation, I'm guessing you've run into this problem. You have a directory. It's got a bunch of Python scripts or Ansible playbooks in it, and yeah, they're way better than CLI copy-paste, but who besides you can safely use those scripts or run those playbooks? It's all a bit fragile, and that makes you irreplaceable, and that's not good. You want to be able to go on vacation or be sick or have dinner without getting a call, which means you need a network automation system that is not fragile, that anyone in your organization can use, and that leverages the automation work you've already done. And iTential gives you all of this. With iTential, you'll be able to run your scripts safely as a workflow that integrates with your change management, your IPAM, monitoring, your ticketing system, and anything else that you need. True network automation. Not something that just saves you some CLI time, but something that touches everything that needs updating and testing when you make a network change. And iTential is low code. You don't have to be a software developer to use it. Whether you're just getting started with network automation or you're deep down the rabbit hole with GitOps and pipelines, iTential can help. Automate from ticket creation to ticket closure with iTential. Find out more at www.itential.com/packetpushers. That's www.itential.com/packetpushers. Well, Dan, you've mentioned Cisco SD-Access several times here along the way. I know it's an important part of the solution, but let's take a step back and explain to people what SD-Access is. Just a few sentences. Give us the overview.
SD-Access is a product Cisco has had on the market for a bunch of years now. It's basically an underlay overlay where you have an underlay of routed connectivity. They actually use the ISIS protocol, and they use the protocol LISP as a database of knowing where everything is and how to get a encapsulated VXLAN packet from where it's coming from to where you're going. So it's got a lot of huge advantages over how we used to build simple networks with spanning tree. There's no more spanning tree, right? Because it's all routed underlay. So that's awesome. And so there's a lot of benefits to it. And it does allow you to virtualize. So within the VXLAN packet, there's a little tag that says what virtual network you're in. And you can't get from one VN to another VN without first basically exiting the north side of SD-Access and hitting what Cisco calls the fusion router. And we've decided to implement the Fusion router as a Palo Alto firewall. We're a Palo Alto shop. And so there we apply policy. Like you're not going to be able to get into the OT network unless you're very particular, like you're maybe an OT server in our data center. And that is allowed to talk to the OT network on the campus. So it's very tied down. We have the ability to, like a firewall is by default, nothing's getting in until you put explicit rules in. So that's how we've decided to implement all of SD-Access.
So you got a packet in a VXLAN. It's encapsulated in VXLAN. It exits VXLAN and gets dumped to the Palo, or the Palo actually does the decap of the VXLAN.
It gets de-encapsulated just south of the Palo Alto, and then when it goes into the Palo Alto, it's a .1Q tag, so that the Palo Alto can tell, oh, you're coming from the standard user VN, or you're coming from public safety VN. Oh, I see you're coming from the OT network. And so on the Palo Alto, we have a whole bunch of sub interfaces, and based on the interface your packet arrives on, because it's got the .1Q tag on the packet. Yeah, it'd be nice if the Palo Alto natively understood VXLAN, and it doesn't do that yet.
I was curious about that. That would have been a bit magical, but then I figured with Cisco SD-Access being what it is, they probably want it to be decapped within their infrastructure. Okay, hand it off to the Palo for policy, then you forward it there in accordance with policy, or drop it, as the case may be, and then probably put a new tag on it, and then it hits a new VNI as it heads out to wherever it's got to go, something like that.
Yeah, Palo Alto actually has something on GitHub where it will use the Cisco's DNA Center API to figure out what VN your IP address is on, and then build a dynamic address group. And we haven't done that yet. Yeah, there's more moving parts that can go wrong. Everything that you put in has more moving parts. And I wonder about the scalability, because it's all basically /32 host routes in a dynamic group on the Palo. So how scalable is that? We haven't tried it yet. We're happy with the current setup. The current setup is pretty straightforward and easy to troubleshoot.
Yeah. And just to be clear, this is obviously a Cisco SD-Access is a software solution, but I assume you need Cisco hardware as the underlay?
Yes. I mean, I guess theoretically, you just need something that can move a packet, because VXLAN is a UDP packet, but that would be crazy to do multi-vendor. I wouldn't want to see that network. No, yeah, we're doing all Cisco networking. We have, Cat 9300s, 9400s at the edge. If we need to extend in what Cisco calls non-carpeted space, so boiler rooms, penthouses, unheated areas, we do use the IE 3300, which is a DIN rail mountable industrial switch, and it acts as a fabric extended node. So it'll hang off a port on the fabric edge node, which is kind of the edge of the VXLAN domain. And then it hands off to an IE 3300, and then you can have that closer to where the actual thing that you're going to try and plug in the boiler room or basement or sub basement. And it doesn't have fans. It mounts in a box. It's much more hardened against temperature and humidity and things. So we've had good luck with those. Those are good switches. In podiums.
Just to be clear, you said you said fabric extender. So I mean, technically, if it's fabric extender, like I think of them, it doesn't have a lot of brains inside. It actually relies on all the forwarding smarts from whatever it's uplinked to. Is it that sort of a device?
Yeah, in Cisco SD-Access nomenclature, you have your fabric intermediate nodes, and then your fabric edge nodes, which everybody plugs into a fabric edge nodes. With the exception that if you have a fabric extended node, You can hang off the edge of a fabric edge node. And then I think some fabric extended nodes are pretty smart, but I think the IE3300, it will basically receive policy from Cisco ICE, put you in the right virtual network, and then I think it does Ethernet .1Q tagging to get you to the fabric edge node. And then once you're there, it's kind of like the Palo Alto integrating with your network, right? Once you get there, I say, oh, you're tagged with VLAN 7. I'm going to put you in the OT network. Because you're right. That is one of the design considerations is they want these extended nodes to be a less expensive thing. They don't need a super powerful Intel processor or something.
No, and there's more magic in just the hardened case for that quote unquote non-carpeted space where the environment might be a little harsher. Spend the money on that. Don't spend too much money on the guts of the thing. Let the decisions happen at the edge. Yeah. So Dan, DHCP, you've mentioned that DHCP is a big potential issue here when it comes to OT networks and I believe SD-Access as well. So how does DHCP fit into all this?
DHCP, so almost all our listeners are probably super familiar with DHCP. And I mean, I've been using it since I don't know when. And but a lot of OT networks don't use DHCP. I'm trying to get them on board with it myself. Because it does help in a lot of areas, and especially with SD-Access. SD-Access, there's something called the IP device tracking database in the Cisco switch that knows who you are by your IP and your MAC address, and then it uses that database to inform the LISP database so that the whole fabric can work correctly. And if your device is not doing DHCP, how's the switch going to know who you are? There are other ways that the switch can figure out who you are by seeing your incoming packets and then saying, oh, I see the source address in the packet header. But DHCP is really the easiest, most robust way for the switch to figure out you've come online, you're on the network. I just snooped the DHCP traffic, and I know exactly who you are. So that's the best use of DHCP and why we try to move everybody to that model as much as we can. You have silent devices. So here's where your problems start. So if they're not doing DHCP, they're maybe doing a static IP, and they have they might send one packet when they boot up, and then they'll be there listening. So that one packet might be enough for Cisco ICE, to see your MAC address, and then Cisco ICE will put you in the right OT network space. But if it never sends a second packet, then the LISP database will never notice who you are. So you have weird edge cases like that. And you quickly, you might have things also. We started to see phenomenons where the device would be working and they'd put it in on a Thursday afternoon, walk away, and then by Monday, the LISP database will have timed out, or some database would have timed out. The device tracking database times out and it forgets who you are, and then you can't talk to the thing anymore. So we developed a couple interesting sneaky tricks. So one sneaky trick we did is sometimes you can just configure the device to configure its NTP settings, which, they frequently didn't do. They don't need the device to have an accurate clock. But once you program it to do NTP and update its clock, then multiple times per day, it's at least sending one packet and getting one packet in response. And that's enough to keep the LISP database and the device tracking database fresh. And then it works like a champ. That was one trick that we did for a few devices. Another one is if you can configure it to send an SNMP trap or syslog messages out, and you don't actually have to give it a legit syslog server. You can send syslog messages to 169.254.0.1. It doesn't care. And its syslog is UDP, right? So it's not waiting for a packet back or a three-way handshake. It just sends a packet out. Boom, I got you. I can see you. You're on the network, and that can refresh the database. So tricks like that we've deployed a couple times. It doesn't save your bacon every time. We got a couple places where it still is weird to work with. We actually have to talk about BACnet IP a little bit, because that is a protocol that's used a lot.
We do, but before we do, I want to ask you about the role of Lisp in all of this, because it's been a while, Dan, since I looked at Lisp, and it did not get widely deployed by the industry, right? I mean, Cisco's using it for this use case, and I don't know how much else. Not a lot. So Lisp isn't something that is fresh in my mind. I remember, or I seem to remember that it did encapsulation. I remember there was a directory service. I remember there was, looking things up and then tunneling to get that packet from where it is to wherever it needs to go. But if I'm remembering that correctly, then I'm a little mystified as to how VXLAN also tunneling, fits into things. Can you clear my mind up on how that works?
Yes. Yeah, yes. If you look up the RFC, you're absolutely right. It was two things. It was an encapsulation technique similar to GRE or VXLAN or any other encapsulation technique the industry uses. But it was also that lookup, that database of encapsulation entry point and exit, what do they call it? Exit router and an entrance router, and mapping you across some sort of underlay. Cisco decided to take LISP for particular reasons instead of BGP, which is BGP is used for EVPN in data centers. And I think other vendors are using EVPN for the campus too. But LISP is a completely different model. LISP is a switch starts up. I know nothing about the world. As soon as I get a packet in and I got to send it somewhere, I got to do a LISP lookup. Very similar to how a DNS caching server would start up and the cache is empty. And it does not try to pre-populate the cache, because to do so would mean you'd never populate it. The whole planet of resource, DNS records could never populate your cache. You got to wait for somebody to ask, and then you fetch the data and populate your cache. Whereas EVPN with BGP, because the model for data centers, I want a vMotion of VM from one leaf switch to another, and I want that to be fast. As you arrive, your MAC address gets shot up to the BGP route reflectors, shot back down to all the other leafs, and you're everywhere all at once. But that model I guess Cisco figured that model would not work well with a campus network and people roaming around. So they chose LISP, which is more of a DNS model with a cache. So that's what they've done. And they did not use the LISP encapsulation part, just the routing and the lookup part.
Okay.
For some reason, they said, no, VXLAN is better for us.
We could think of it as instead of EVPN or VXLAN EVPN, it's like VXLAN LISP. It feels like the way we're learning destinations is using the LISP directory function, not the NCAP function, but again, just the directory function.
Right.
Boy, I'm going to have to read up on that, because in my mind, it's like, is that a one-to-one kind of thing? Because it feels like they're pretty different from what I remember of LISP. I'll have to dig in. But I guess in the end of the day, we're accomplishing the same thing.
The reason why they used VXLAN is because, well, I think it's more modern and people like to reinvent the wheel every single 10 years or something. But also they extended VXLAN to include the SGT, the source group tag, or what I think the marketing people now call the security group tag. And that lets you do some microsegmentation within the VN with a 16-bit tag. It also has the virtual network number, which is a 24-bit field in the VXLAN header. So now you can have a bunch of VNs, which is what we're doing here with our OT network. And I don't think that any of that is in the LISP encapsulation. I'd have to check, but I think in that regard, VXLAN is much more flexible for what people wanted to do with their enterprise networks.
So LISP is essentially just keeping track of where should this packet go.
Yeah. So once you come onto the network, your edge switch says, oh, this person with this IP and this MAC address, he lives at, campus switch out on the edge with this loopback interface. Mm-hmm. And then when somebody else on the fabric wants to send me a packet, it gets into their edge switch, encapsulated, and sent to the loopback interface of my closet switch. And once it arrives, it de-encapsulates it and delivers the packet to me.
Got it. All right, we ready to go back to BACnet. You want to talk about that, Dan?
Well, actually, that's a perfect segue, because one of the things SD-Access does, and the LISP and the VXLAN system does, is it proxies the ARP process. It knows where you are. So when somebody ARPs to find out what your MAC address is on the same broadcast domain, and there's no broadcast domain to speak of anymore, it proxies all that. It doesn't flood an ARP frame across the entire VLAN or subnet, whatever you want to call it. So there's a feature called layer 2 flooding suppression that's turned on by default for all the subnets on SD-Access. That does not work with BACnet IP. So this OT protocol has its own type of ARP system to find neighbors. It's called a who is, and then the neighbor responds with a I am response. And it's implemented with Ethernet frames, FFFFFFF, like broadcast frames.
Mm-hmm. Yeah.
So for Siemens, Johnson Controls, you have to turn on layer 2 flooding in DNA Center. We use DNA Center to program all the switches. And we just do it for the Siemens subnet, and we do it for the Johnson Controls subnet, and we do not do it for GE because they don't use that. Thankfully, they don't use BACnet IP. We don't use it for some of the other OT networks. Because it's a flooding type of protocol to find its neighbors, the vendors said do not make it bigger than a /24. Because it just it'll kind of collapse. It'll be too much. It's too chatty. In contrast, I have networks that have Windows and Mac machines on it that have like a /17 or a /18 because I'm not worried about ARP and broadcast domains anymore with SD. That's one of the nice parts about SD-Access. I don't have to worry about that anymore. But for the OT networks, no can do. I got to make it a /24 and cross my fingers that they don't start needing more than a couple hundred machines, OT devices. If they did, I guess I'd have to spin up another subnet, call it Siemens Part 2 or something.
Yeah. Well, then
because it's too chatty.
Bridge the flood and learn between them. If they're all learning on layer 2, you'd have to do something like that. I don't know.
Well, they have
the
a
BACnet
special
Ethernet only, or is it IP as well?
It's IP.
Okay.
But they sent out a special, and it uses, I believe, UDP. They have a special port number for UDP traffic, and it's its own thing. Actually, they have a way of BACnet IP devices that are on different subnets being able to talk to each other. They use a BACnet broadcast management device. It's a BBMD. It sits on the subnet. It listens for the all Fs Ethernet broadcast.
Yeah.
For that particular UDP packet for BACnet IP. Once it gets that broadcast, it takes it, turns it into a unicast, and sends it to all the other BBMDs that it knows about. It actually has a broadcast distribution table.
Yeah.
Think of the broadcast distribution table, the BDT, as like a routing table, like what us network engineers would consider a routing table. It knows about all of its neighbors on other parts of the network, and it'll send it out. Now, here's the fun part, though, is once it gets to the remote BBMD, it'll take it and turn it back into a broadcast and spray it out onto that broadcast domain for the other person that it was headed for to hear. And then that other person will say, oh, that's me, and send a unicast back to the original party. So basically, they've created a gigantinormous broadcast domain across multiple subnets. Everything that us network engineers would never want to ever see done.
Well, it feels closer to a multicast tree in some ways. It's not, it's not purely broadcast because you've got these relays to all the intermediate devices, whatever your acronym was. I already forgot.
Yeah, the BBMD. But it has to be designed with, if it starts to get big, they have to design the broadcast distribution table to not go everywhere, to go to a central hub BBMD and then only send it out to spokes that are really interested or should hear that broadcast. Scoring special points for if you accidentally have two BBMDs on the same subnet, and then you might cause a loop and melt the whole thing down.
So you wouldn't want to put your BACnet IP devices on like old switches that don't have all the fancy Cisco SD-Access because you do actually want to do port by port level control. Is that right?
Well, that's not going to be your limiting factor, probably. What your limiting factor is the CPUs in these devices, the OT devices, because they might have pretty minimal CPUs. And if they see too many broadcasts, they start to get a little crazy. We did have some.
You're saying the BACnet. You're saying the vendor of the device that's using BACnet is saying don't go bigger than a /24.
Yeah, absolutely. Yeah.
Oh, okay. I took you to mean that like Cisco and SD-Access guidance was saying, don't do this.
No, the
So
vendor said don't go big. Don't try to do,
oh,
I mean,
okay.
I normally wouldn't want to build if it was a truly a broadcast domain like we typically know it to be, you try not to build things too big.
Yeah.
Historically, because of momentum and technical debt, I've seen OT networks that have gotten too big, and they do start to act a little flaky.
Hmm.
They'll start to act flaky, and if you don't step back and redesign and work with facilities to redesign things, they move from flaky to downright hokey, and then you have problems. So yeah, it's a chatty protocol. Normally, network engineers, we don't really need to know too much about the things that are riding on the network. It's an application. It does its thing, right? We know about DNS and DHCP because those are protocols that we have to be intimately aware of because they're part of the proper functioning of the network. But I mean, if you want to run HTTP over it and pull up cat videos, I don't care. But here in OT, it pays to know a little bit. I hope I'm not representing myself as being like an expert in BACnet IP, because that is not my intention. I am not an expert. I've organically absorbed a lot of this information from our vendors, and they've told me things I should not
Well, you
do.
you're in the same situation a lot of network engineers have been. I've been in the situation of having to deal with some odd protocol, like, oh, it doesn't know anything about IP. It's Ethernet only. All it talks is frames, and having to build the network to support that connectivity there, or devices that need to talk layer two, but we had shut that functionality off for some reason, or the two devices that needed to talk layer two were separated accidentally because no one told us that was a design requirement. These kind of things, and then, as you say, in those cases, you end up needing to understand at least what's happening down there at the at layer two, layer three, and so that you can accommodate whatever those needs are.
Yeah, and when you find sometimes a vendor that is supporting the OT network, and then you find their team that knows how to do networking, it's really an exciting find because they're
Hmm.
like, oh, this is a guy that I can talk to, and we can start to have a meeting of the minds and really get this thing to scale up and get bigger and bigger and bigger because these OT networks are getting big. I mean, we renovated a building. Now, albeit it was a multi-story large building, but uh, they started by telling me, "Oh, there's going to be like 20 devices in this building on the OT network." I said, "Great." And we already had a /24 provisioned for that part of the campus, and I can add 20 devices, no problem. And then they said later, "Well, there's 700 plus devices behind those 20 gateways."
Okay.
So, I mean, I can I can do address planning for 700 devices. I mean, you got the whole 10 space, but I have to be careful with my 10 space. It's actually not huge when you're talking about 300 buildings, and so I have to size things properly and get it to work. And they don't have to necessarily route to us because they are doing that gateway thing. But if there's going to be hundreds and hundreds of these OT devices popping up in a typical size, medium sized building or a large building, network engineering has to grapple with this. We have to know what's going on and not just run around thinking well, I don't want to deal with it. I don't want to know about this. I'd rather not. Let facilities doesn't want to really deal with network engineering. Network engineering doesn't want to deal with facilities, and then you have things siloed, and then you can't get to those benefits like that huge multi-million-dollar project where we're saving so much money just because they're able to integrate and run software that can query these devices and see their health and understand when things are going poorly. And so that's the payoff.
So, quick question about BACnet. You said there are some OT vendors who are using BACnet and some who aren't. Are the OT vendors that are using BACnet, do they also have like subtleties or differences in how they implement BACnet that you have to be aware of as well? Like vendor A might do it slightly differently from vendor B, as sometimes happens with protocol implementation.
They yeah. So there is differences, for instance, on how Johnson Controls does it versus Siemens, the two big BACnet IP vendors that we deal with here. Um, they, I guess, both will claim, oh, there's elements of the standard that we do slightly differently that we do much better than the other vendor. So
We
the
embrace and
typical
extend.
vendor, Yeah, typical our product's much better than the other product. This this problem that you would have if you designed the network poorly, you're not going to have with our product, and
Mhm.
vice versa. So things like that do happen. Um, core knowledge of the protocol is a little difficult because it's not an IETF standard that you can just pull up.
Mm.
It's I think ASHRAE that runs the standard. So it's difficult to get your hands on and like parse it. It's not as readable as, I say, an IETF standard. So that's a little bit of a hurdle for us normal IT people. Um, but yeah, the implementation is a little bit different.
It's just an added challenge for you.
Yeah, if I could get my hands really wrapped around BACnet IP, I would consider myself very fortunate because it's the other weird protocols, the other weird stuff that really throw you. We had a device that would not work, and it wouldn't work. We were trying it, and come to find out, it had a little daughter card on the thing. I think it was a steam pipe monitor, steam flow or something, and it had a little daughter card on it that had the RJ45 Ethernet jack on it,
Mhm.
and it couldn't get out of its own way to save itself. It was just some really 15-cent processor that would process very minimal Ethernet, whatever it was doing. And the solution ended up being to bypass the daughter card. And I think we recommended they buy like a Moxa, which is an OT vendor that we could support and that we had run through our lab and we knew worked well. And so they bought a Moxa to interface to the RS-232 port on the Steam sensor, and we just got rid of the daughter card. It was just it was no hope, right? We just gave up. We had another
Wow.
device. We had some gamma radiation detectors because we have a group that had MRI machines. And I
Uh-huh.
guess
Hmm.
by law, they need these gamma ray detectors to stop some sort of Bruce Banner type of event. And we came to find out that the software that talked to the gamma radiation detectors had a special way of mapping the IP address that you would type into the software and the MAC address. The MAC address was not burnt into the device. I said, why are you doing it weird like that? And it turned out the device doesn't implement ARP at all.
Mhm.
Okay.
Now, if you had an algorithm to map the IP address to the MAC address, I guess you wouldn't need to do ARP, but that means it doesn't work with SD-Access.
Mm.
So we ended up that the Windows 10 machine that ran that specialized software had two network cards. One network card we connected to SD-Access, and the other one we connected to just a small switch. And all the gamma ray detectors were in one building, and we just wired it up to that one small switch, and they're not on SD-Access. They're on their own special network. Because if you haven't implemented ARP in your IP stack, I can't deal with you. I don't know what to do.
That's where you draw the line.
We had another product that was a building automation control system, and we were actually talking to Cisco Advanced Services, and they had the exact same product in one of their SD-Access pilot buildings out in San Jose,
Mhm.
California. And they said they worked directly with their facilities group to try and get this stuff online. And it was some sort of Ethernet weird protocol that worked over Ethernet and didn't really do IP, but it could do IP. And they tried to turn that feature on, and it never quite worked as they wanted it to work. And they said, we just replaced them all with newer versions of that product from that same vendor. So that doesn't scale very well if there's hundreds of them or thousands of them. So they said that, I mean, there was only a few of them that they got rid of. And it turned out that our organization had the same exact product, but only a few of them. And we reported back to the facilities. I was like, we just had a 4-hour conference call with Cisco. They couldn't get it to work. I don't think we're going to get it to work. And we ended up throwing ours out too and replacing them. It was just a few of them, I believe, with the newer version from the same vendor. So that was the solution. That's like kind of a non-solution. That's not really a solution, but it was the best solution we had for that particular kind of device.
Huh.
Well, what's in the future for your OT network at Yale, Dan? I'm curious, especially about IPv6 support. It sounds like we've been talking very IPv4 so far today.
They're not, I get the sense when talking to the vendors, there are not a lot of customers asking them for V6 support. I don't think it's a thing that people are really driving towards. But you know what? If you're going to put 470 devices in each building, I really wish you would do V6 I could just give you a /64 and say, go at it.
Hmm.
Because
And you're
with that
talking to
kind
the
of,
Siemens, the Honeywells, the GEs of
yeah,
the world with this about the V6, yeah.
yeah, with a /64 on IPv6, the difference between 470 devices and 20 million devices is a drop in the bucket. Like, I don't care how many devices you deploy at that point, but instead with V4, I got to size it properly. I can't give you too much space because that wastes too much space. It would be
Hmm.
awesome if they did V6. Um, they are working on for the BACnet IP vendors, they're working on BACnet SC. So this is a newer version of the protocol and it turns things upside down. So for a BACnet SC device, the OT device out in the field, the IoT device, reaches out and talks to the server on the back end, not the other way around. And that's super important and helpful for programming your firewall rules. It's helpful because it supports DHCP really naturally. Like, it just comes on the network. The out of box experience is super easy. It can do DHCP. It comes on the network. It reaches out and talks to the backend, supervisor or SCADA system, and you're done. I like the model of a wireless access point. Nobody tries to do static IPs on wireless access points anymore because you break it out of the cardboard box, you plug it in, does DHCP, it talks to the wireless LAN controller, boom, it's in. And so as they move to that model, it's going to become a lot easier to deploy hundreds and hundreds of these devices. And I think the vendors are seeing this and they're trying to move in that direction. And it's a slower process than what IT is usually used to because we're usually flying forward, changing out the aircraft engine while we're in flight. That's
Yes.
IT for you, right? And this is like HVAC people and, you know, six
Industrial
nines of
control systems.
reliability.
Yeah.
Yeah. So
Yeah.
they're getting there. They're getting there. I'm hopeful. It's going to be quite a while before I retire. So I'm hopeful that we're going to see more of BACnet SC as a protocol. And then some other vendors in their gateway, they're doing REST APIs. So on the
Hmm.
back end, behind the gateway, they might still do BACnet IP or some really old protocol, but on the front end, they'll have a REST API or webhooks or something like that.
It's probably not a good idea to move fast and break stuff when you're the control system for an oil refinery, for example.
Oh yeah, when you're talking that level, it's bad enough if the air conditioning gets knocked out for a building, but yeah, if you're refining chemicals at a plant, it starts to become super bad.
Yeah,
But even for us, yeah, we want our networks to run smoothly, and
of course.
so
Hmm.
that's that piece of the OT network, that heritage that those vendors and all those support people bring forward to our IT networks, we want to maintain.
Sure.
We want to retain that and say, hey, you're onto something there. I want my network to come up to your standard, not you come up
Right.
to my standard, which is everything breaks down. Oh, just reboot your Windows machine. That's why your microphone on your Zoom call doesn't work. No, I want to go to your standard, not drag you to mine. And that collaboration with the facilities department is, I think, really bears a lot of fruit if you look at it from that angle.
Mm.
Well, Dan Massameno from Yale, this is another great conversation with you. One of the things that people really appreciated about the last time you were on was how much detail we were able to get into. It really helps folks as they're troubleshooting with their own problems and working on their network designs and architecture. We had the same kind of conversation today, Dan. So thank you for being able to be so transparent, share so much detail about what you're doing at Yale.
Thank you. Yeah, the podcast that packet pushers have had where they really dig in and say, "Hey, this is exactly how this works," is some of my favorite podcasts. So yeah, I'm happy to collaborate and share knowledge so that nobody, we're not all reinventing the wheel. And this is a really exciting field too, because we're going to be seeing a lot of this as people turn to green buildings,
Yeah.
and it's it's been a lot of fun working on these kind of networks.
Dan, is LinkedIn the best way for folks to find you if they have questions for you?
Yeah, LinkedIn and blogs on packetpushers.com are excellent. And I like writing about these topics as well. We have a couple, I'm hoping to get another couple blogs out on OT and OT adjacent technologies with SD-Access. And so you'll probably see some of that coming up as well.
Yeah, speaking of that, I'm glad you reminded me, Dan. If you're out there in the audience listening and you want to dig in more, Dan submitted 4 blog posts to accompany this podcast that we're going to be publishing on packetpushers.net. We will have those, and Dan will be listed as the author, so you can search that. Those posts will go up and will augment the discussion we had today around OT networks and Cisco SD-Access. So if you're still out there listening at this point, we're at the end of the show. Good job. You made it to the end. And thanks for listening to Heavy Networking today. Of course, this has been part of the Packet Pushers network of fine podcasts, blogs, newsletters, and videos for your professional career development. Visit packetpushers.net or search for Packet Pushers in your podcast client to find all the shows that we're publishing these days. Also join our absolutely free for everybody Slack channel. There's over 3,000 IT, cloud, DevOps, and networking professionals just like you in that group. Take part in the conversation. It's a marketing free zone. You can ask questions, get feedback, and share your own opinions and knowledge. The invite link is at packetpushers.net/community, and we'll see you in there. Last but not least, remember that too much networking would never be enough.